Okay, so now I picked this number 10 that is in the homework. This is to kind of to push the limits, kind of our limits, not the function of limits, because this is kind of a classical type of problem where you try what we use so far and you find out that hey, it doesn't work. And this is going to happen often in calculus. Then what we do is we switch, whether we switch from trig to algebra or algebra to trig, or stuff like this. But you'll see what I'm talking about in this example. This is a function x to 2/3. If a is not 0, find g prime of a, and so the question. So if we want to use so far what I used in all other examples, if you look at the videos, I talked about two parts for the derivative. Then we use one for definition, and we use that mostly. And if we want to use that here, let's see, and we say h approaches 0, then you're going to get x plus h 2/3, right, minus x 2/3 over h. Well, as we know, we need to get rid of h or find a way, because h approaches 0, we can use the substitution for h as 0 there. And here, since x is going to take a, so it's going to be this as a 2/3. So pretty much we're stuck right there, because there is no algebra that's going to play some type of magic on this thing to solve. But if you look at the previous videos, we also had another way of defining this thing, when we say that if you're not talking about h approaching 0, if the goal is a, you want x to approach a, right? Which is the same sense. And if you do that, and in that video I talked about that now you're not doing h approaches 0, but you do x approaching a. So which means g of x minus g of a over x minus a. And this one will have a trick that probably you've never done. And if you've done it before, please let me know. I want to know what type of problem you used it in. All right, but so it goes something like this. And here, of course, this, if it's not familiar, 2/3 and x 2/3, that's still a difference of squares, right? Because 1/3 squared minus a 1/3 squared. So it's still a difference of squared, because when you have two exponents, it's 2 times 1/3. So it is x to 1/3, a 1/3, and x with the plus in between. Okay, so we can do that and see what happens. All right, so this is the trick I'm talking about. It looks like this x minus a has some connection with this 1/3 and x 1/3 and plus and this and that, right? But it's not super clear. This is where we introduce a new trick, which is somehow here, to get rid of this, we need one of these, right, that are in the numerator to cancel. So here we're going to use a trick of 1/3. We just did a difference of squares, right? So now we're going to do a similar trick by introducing the difference of cubes. So we're going to say, we're going to make this as a difference of cubes, right? Because what is really a difference of cubes? If you do this, you see, so let's just check. Let's just check, what is this? This is x2 3/3 minus a to 3/3, which is x minus a. So we really, the way we figure out this is going backward. X minus a over a, we know we want the third there, so it has to be 1 and 1, which is 3/3. Then put 3 outside, and you get this form. So really, the bottom is difference of cubes, even though it's not written as difference of cubes. So let's put difference of cubes at the bottom, which is that another equivalent form for it. So now we can use difference of cubes formula, which says this thing. Then you square the first one, and you multiply them, and you square the last one. All right. And now that will allow for this to cancel. And now this allows us to 1/3 plus a 1/3, x 2/3 plus x 1/3, a 1/3 plus a 2/3. Then now put you know, a for x because of this limit. So it's going to be a to 1/3 plus a to 1/3, a 2/3 plus a 1/3, a 1/3 plus a 2/3. So this is 2 of a 1/3. This is 1, and this is a 1/3 times a 1/3. So here, right, it's going to be a 1/3 plus 1/3, which is 2/3, right? So this is 1, and this is 1, and this is another one. So 3 of them. So the final answer here is going to be 2, 8 1/3 over 3, 2/3. That's 2 prime of a. All right. I think that's it, and I will close this part. Thank you.